All right, so in this lesson, we will represent dilations on a coordinate plane. So we're going to represent dilations. Remember, dilations is a change in size. A change in size. Given a pre-image. So we're going to be given a pre-image, given a pre-image, and image on the coordinate plane. So we're going to represent the change in size given a pre-image and an image. Before we get started on this, it's important that we talk about some like these words, okay? So the word dilated. The word dilated will usually refer to your pre-image, or like your original shape. Or you can say like maybe your old shape. You'll hear me say old a lot because I think that's easier to get the point across sometimes. And your dilation, the word dilation will usually refer to or usually reference your image, which is like your new shape. Your new shape. So let's read this. It says polygon ABC was dilated. So ABC was dilated. Dilated, old, original, pre-image. So ABC was dilated. I guess I could do this. Was dilated. And it became a WXYZ. So that's like the new one. Represent the dilation algebraically. So ABCD was dilated. So ABCD, this is my old one. This is my pre-image, and that means WXYZ is my new one. So it goes from this shape to this shape. It like blows up, right? So we want to represent the dilation algebraically. So what we're going to do is let's take one of our open, let's take B. We can see that B ends up referring to or becoming X, right? We can see, I guess I can put it like this. So B becomes something, C becomes something, Z becomes something, W becomes something, right? They become X, Y, Z, W. X, Y, Z, W. Oh, what in the world was I thinking when I did this? All right, X, Y, Z, W. Okay. Now, we know that we will be multiplying here, right? I'm going to put that in green. We're going to multiply by something. We just don't know what. So what you do is you just take any one of these. It doesn't matter which one. It doesn't matter which one because they will all give you the same answer. So let's take B. So 2, 2. That's easy. Let's do B, which is 2, 2. And then we'll make this one in green instead. Actually, give me 1 second. All right, look at that. Look at that beautiful color change. So B was 2, 2, and it became, so let's use green. It was multiplied by something and became by a scale factor and became X, which is 3, 3. Oh, I forgot to put this here. So it was 2, 2. It became 3, 3. Now remember, I've preached this like so much. If you have a number, you multiply and you get another number. If you don't know what you multiply by, like we had 2, we multiplied by the number, we got 3. If we don't know what we multiplied by, then we have to divide going backwards. So the scale factor, which is the number we multiply by, our scale factor, my scale factor, you would get that by dividing 3 divided by 2, or this 3 divided by 2, which is 1.5. So both of these are correct. You can't reduce this anymore. You can't reduce this anymore. Like, you can't divide the 3 and the 2 by anything. This is it. So these are your scale factor. This is your scale factor in fraction form, and this is your scale factor in decimal form. So what this means is that you're multiplying by 1.5 times 1. So 2 comma 2 times 1.5 is 3 comma 3. And I'm here to show you, well, before we do that, let me just show you how to represent it. Oh, no, I have words down here. I'm going to show you that we can do, like, you'll get the same answer doing any of these. So I'm going to write it right here. So let's use C to Y. C to Y. So C, which is 4 comma negative 2. Became Y, which is 6 negative 3. So to get my scale factor, you can just write SF. You have to do 6 divided by 4. Remember, we don't know what we multiply by. We don't know what we multiply by, so we divide. You can either do 6 divided by 4 or a negative 3. Let me do it slightly different. Or negative 3 divided by negative 2. I'm going to do 6 divided by 4. And if you reduce it, because you can't divide it, right? You can't divide that cleanly. You get 3 over 2. Oops. Let me write those 3's a little better here. Divide by 3. Divide by 3. And you get 3 over 2. Which is what we had before, which was 1.5. Which is the same as we had before. It should be the same. So that was C to Y, so 1.5. Now, you don't have to do this for every single one. I'm here just to show you. Like, you don't have to do B to X, C to Y, D to Z, W to W. What is that? All right, fix it. So you don't have to do B to X, C to Y, D to Z, A to W. You don't have to do all these. Like, I did 2 of them. You don't even have to do 2 of them. Just do 1 of them. I just wanted to show you you'll get the same answer. It doesn't matter how you do it. Like this negative 3 divided by negative 2 will give you positive 3 over 2, which is 1.5. So let's talk about our statement, or let's fill out the statement. So A, B, C, D was dilated by a scale factor of 3, well, I should put that in green, 3/2, which is also 1.5. I can represent this transformation. Remember, transformation is a change. Algebraically using the coordinates. Let's use fraction form. 3 over 2 times x. 3 over 2 times y. Oh, that was my mistake. We can represent it using the coordinates x comma y into 3/2 x and 3/2 y. You could have also used the 1.5 if you prefer. All right, let's do this last one a little faster. So polygon XYZ is a dilation. So, we actually have to go up here. XYZ is dilation. Dilation, that means it's the image, it's the new one. So this is the new one. XYZ is dilation. That means ABC is the original. So XYZ is dilation. So XYZ is the new one. ABCD was, okay, so it's going from outside to the smaller one. And, okay, cool. So let's write our points out. So we had A, we had B, we had C. They were multiplied by a scale factor and became X, Y, and Z. Oops. X, Y, Z. We do not currently know what that scale factor is, so let's figure it out. So I'm going to use A to X. Well, I could, but you see, this is like a weird decimal. Like, I could do my best guess, but that's not gonna be good. I could use Z and C, and I could use Y and B. So I'm gonna use this one, B and then Y. B is 6, -3. And then it was multiplied by a scale factor. It was dilated by a scale factor. And became Y, which is 4, -2. So all I have to do to find my scale factor, I'll leave some space. Remember, my scale factor is the number I multiply by. And I have to do either 4 over 6 or -2 over -3. I'm going to do -2 over -3. -2 over -3. Well, we know a negative over negative is a positive. And we can't reduce this anymore, so we're stuck. We're done. 0.66 repeating. There we go. Okay, that doesn't look right. Better. So, XYZ is a new one. This was the original one. It multiplied by, I'm going to put 0.66 repeating this time. Oh, we didn't even use that one. I mean, I guess they're all the same, right? And so this was the original one. So I'm actually going to label this. I didn't begin with, but it would have been helpful. That is my new one. This is my old one. Nope. My old one. And that would have helped here. So this is my old one. I guess I'll write old one. And this is my new one. This is my image. We can see that I got smaller, right? Okay, so let's do it. So that's my old one. So that means my old one, my original one, my pre-image, which was ABC, was dilated by a scale factor of 0.66 repeating, which is 2/3. And I can represent this transformation, this change, algebraically using the coordinates x comma y, and then it becomes 0.66x and 0.66 repeating y. Cool. So that's it. No matter what you do, if you divide the correct way, or between any of these pairs of points, then you'll be fine. That's it. Thank you.